Hello friends, as you know, myself Ankita Shinde from Sadhana Education English Medium School, Nasik Road, Nasik. A very warm welcome to Borade Math Academy. At first, I would like to say specially thanks to Borade sir for giving me this wonderful opportunity. Thanks sir. So Science Part 1, Lesson number 1, Gravitation. What is meant by gravitation? So, gravitation is a Greek word which means gravita, means weight. Okay, this is our chapter's name's meaning. So, let's start gravitation. Please observe the figure. The phenomena of gravitation was discovered by Sir Isaac Newton. As the story goes, he discovered the force by seeing an apple fall from a tree on the ground. He wondered why all apples fall vertically downward and not at an angle to the vertical. So, introduction to the great scientist. Great scientist Sir Isaac Newton. Sir Isaac Newton, 1642 to 1727, was one of the greatest scientists of recent times. He was born in England. He gave his laws of motion, equation of the motion, and the theory of gravity in his book Principia. Before this book was written, Kepler had given 3 laws of describing the planetary motions. However, the reason why the planets move in the way described by the Kepler's law was not known. Newton, with his theory of gravity, mathematically derived Kepler's law. Newton did ground-breaking work in several areas including light, heat, sound and mathematics. He invented a new branch of mathematics. This is called calculus and has wide-ranging application in the physics and mathematics. He was the first scientist to construct a reflection telescope. So, circular motion is our next topic. As along as we are holding the string, we are pulling the stone towards Earth, that is, towards the center of the circle, are applying a force towards. The force stop acting if we are release the string. In this case, the stone will fly of all along a straight line, which is the tangent to the circle at the position of the stone when the string is released. Because of that, it is the direction of its velocity at the instant of a time. The centripetal force, observe that figure, a force acts on any object moving along a circle and it is directed towards the center of the circle. This is called the centripetal force. Centripetal means the center seeking, that is, the object tries to go towards the center of the circle because of this force. So, Kepler's law. So, let's start. Planetary motion had been observed by astronomers since ancient time. Before Galileo, all observation of the planet position were made with neckties. By 16th century, a lot of data were available about planetary position and the motion. John Kepler studied this data. He noticed that the motion of a planet follows certain laws. He stated 3 laws describing the planetary motion. Kepler's first law. Observe that figure. The orbit of a planet is an ellipse with the sun at one of the foci. Kepler's second law. Observe that figure. The line joining the planet and the sun sweeps equal areas in equal intervals of time. Kepler's third law. The square of its period of revolution and the sun is directly proportional to the cube of the mean distance of a planet from the sun. So, our next topic is Newton's universal law of gravitation. Observe that figure that Fg is equal to g m upon m2 upon d square. Okay, observe that figure. According to this theory, every object in the universe attracts every other object with a defined force. This force is directly proportional to the product of their masses of the two objects and is inversely proportional to the square of a distance between them. So here, small g stands for gravitational force between the object, okay, and the capital G stands for the universal gravitation, uniform circular motion, or magnitude of a centripetal force. So friends, let's start. The distance traveled by the planet in one revolution is equal to perimeter of the orbit 2 pi r. R, distance of the planet from the sun. Time taken, period of revolution t. So v is equal to v for velocity. Distance travelled upon time taken is equal to 2 pi r upon t. F is equal to mv square upon r is equal to m in bracket 2 pi r upon t whole bracket square upon r is equal to 4m pi r upon t square. Multiplying and dividing by r square, we get F is equal to 4m pi square upon r square into r cube upon t square. According to the Kepler's third law, t square upon r cube is equal to constant k. F is equal to 4m pi r upon r square k constant, but 4m pi square is equal to or upon k is equal to constant. Therefore, F is equal to constant into 1 upon r square, that is force is directly proportional to 1 upon r square. So I think, did you know? You must have knowing about the high and low tides that occurs regularly in the sea. This level of a sea water at any given location along sea shore increases and decreases twice a day at regular intervals. High and low tides occurs at different times at different places. The level of water in the sea changes because of the gravitational force. High and low tides occurs at the different times at the different places. The level of water in the sea changes because of the gravitational force. Excreted by the moon, water directly under the moon gets pulled towards the moon, and the level of water there goes, causing high tide at the place. Earth gravitational force. Observe that figure. When we throw a stone vertically upward, this force tries to pull it down and reduce its velocity. Due to this constant downward pull, the velocity becomes zero after a while. The pull continues to be exerted and the stone starts moving vertically downward towards the center of the earth under its influence. Earth gravitational acceleration is 9.807 meter per second square. The Earth exerted gravitational force on object near it according to the Newton's second law of motion. A force acting on a body results in its acceleration. Thus, the gravitational force due to the Earth on a body results in its acceleration. This is called acceleration due to the gravity, denoted by small g. Acceleration is a vector as the gravitational force on any object due to the Earth is directed towards the center of the Earth. The direction of the acceleration due to go, it is also directed towards the center of the Earth. that is vertically downwards. Value of a g on the surface of the earth. Here is a small g, means the acceleration of the earth, gravity. So we can calculate the value of a g by using the Newton's universal law of gravitation for an object of a mass m situated at a distance r from the center of the earth. The law of gravitation gives F is equal to big G m upon r square. M is the mass of the earth. F is equal to mg. From third and fourth, mg is equal to big G m1 m2 upon r square. Small g is equal to big G m upon r square. If the object is situated on the surface of the earth r, small r is equal to big R, radius of the earth. Thus the value of g on the surface of the earth is. So here small g is equal to big G m upon r square. The unit of g in SI unit is meter per second square. The mass and the radius of the earth are 6 into 10 raised to 24 kg and 6.4 into 10 raised to 6 meters respectively. Using thus in equation 6, we get g is equal to 6.67 into 10 raised to minus 11 into 6 into 10 raised to minus 10 raised to 24. Sorry, here is 24 upon 6.4 into 10 raised to 6 whole bracket square is equal to 9.77 meter per second square. What we get? We get g is equal to 6.67 into 10 raised to minus 11 into 6 into 10 raised to 24 upon 6.4 into 10 raised to 6 square is equal to 9.77 meter per second square. Is equation 7. This acceleration depends only the mass m and the radius r of the earth, and so the acceleration due to the gravity at the given point on the earth is the same for all objects. It does not depend on the properties of the object. So today's next topic is variation in the value of small g, means acceleration of the gravitation. So first is change along the surface of the earth. Will the value of g be the same everywhere on the surface of the earth? The answer is no. The reason is that the shape of the earth is not exactly spherical, and so that the distance of a point on the surface of the earth from its center differs somewhat from a place to place due to the rotation and the earth bulges at the equator and it's flatter at the poles. Its radius is largest at the equator and the smallest at the poles. This value of g is thus highest 9.832 meter per second square at the pole and decreases slowly with decreasing latitude. It is lowest 9.78 meter per second square at the equator. Second, variation in the value of g, b point, change with height. As we go above the Earth's surface, the value of r in equation 5 increases and the value of g decreases. However, the decrease is the rather small for height, which are small in comparison, and to the Earth's radius. For example, remember that the radius of the Earth is 6,400 kilometers. If an aeroplane is flying at the height 10 kilometers above the surface of the Earth, its distance from the Earth's surface changes from 6,400 kilometers to 6,410 kilometers and the change in the value of G due to its negligible on the Earth. On the other hand, when we consider an artificial satellite orbiting the Earth, we have to take into account the change in the value of G due to the light change in the distance of a satellite from the center of the Earth. Some typical height and the value of G at the distant height are given in the following table. Variation in value of G changes with the depth. The value of G also changes if we go inside the Earth. The value of R in equation 5 decreases, and one would be think that the value of G should be increased as per the formula. However, the path of the Earth which contributes to the gravitational force felt by the object are also decreases, which means that the value of M to be used in equation 5 also decreases as a combined result of a change in R and M. The value of G decreases as we go deep inside the Earth. Our next topic is mass and the weight. Mass. Mass is the amount of a matter present in the object. The SI unit of the mass is kg, kilogram. Mass is a scalar quantity. Its value is the same everywhere. Its value is same everywhere. Its value does not change even when we go to the another planet. According to Newton's first law, it is the measure of the inertia of an object. Higher the mass, higher the inertia. Weight. The weight of an object is defined as the force with which the Earth attracts the object. The force F on an object of a mass F on the surface of the Earth can be drawn or can be written using equation 4. Gravitational waves. Our next topic. Waves are created on the surface of the water when we drop a stone into it. Similarly, we must have seen the waves generated on a stream when the both its ends are held in the hand and it is shaken. Light is also a type of a wave called the electromagnetic waves. Gamma rays, X-rays, ultraviolet rays, and infrared rays, microwaves, and the radio waves are the different types of electromagnetic waves. Astronomically, objects emit, thus the waves are. We receive them using our instrument. All our knowledge about the universe has been obtained from those waves. Gravitational waves are a very different type of waves. They have been called the waves on the fabric of a space-time. Einstein produced their extent in 1916. Those waves are very weak and it is very difficult to detect them. Scientists have constructed extremely sensitive instruments to detect the gravitational waves emitted by the astronomical sources. Among those, LIGO, laser and interferometric gravitational wave observatory is the prominent one. Exactly after 100 years of their prediction, scientists detected that the waves coming from an astronomical source. Indian scientists have contributed significantly in this discovery. This discovery has opened a new path to obtain information about the universe. So friends, please tell me, did you know the value of a G is the same for all objects at the given places on the Earth? Thus, any two objects, irrespective of their masses or any other properties, when drop, drop from the same height and falling freely, which reaches the earth at the same time. Galileo is said to have performed an experiment around 1590 in the Italian city of Pisa. He dropped two spheres of the different masses from the Leaning Tower of Pisa to demonstrate that the both spheres reaches the ground. At the same time, when we draw a feather and a heavy stone at the same time from the same height, they do not reach the earth at the same time. The feather experiences a buoyant force and a frictional force due to the air, therefore floats and reaches the ground slowly. Later then, the heavy stone, the buoyant force and the frictional force on the stone are much less than the weight of the stone and does not affect the speed of the stone much. Recently, scientists performed this experiment in the vacuum and showed that the feather and the stone indeed reached the earth at the same time. So, our next topic is gravitational potential energy. So, let's start. Please observe that figure. Gravitational potential energy is the energy possessed or acquired by an object due to the change in the position when it is present in the gravitational field. In simple terms, it can be said that the gravitational potential energy is an energy which released to the gravitational force or to gravity. Next topic, escape velocity. Escape velocity is the minimum speed needed for a free, non-propelled object to escape from the gravitational influence of a massive body, that is, to achieve an infinite distance from it. Escape velocity is a function of the mass of the body and distance of the center of the mass of the body. So friends, please tell me, did you know this? Weightlessness in space. I think we all know this. Space travelers, as object in the spacecraft, appears to be floating. Through the spacecraft, it is at height from the surface of the earth. The value of a small g there is not zero. In the same station, the value of a small g is only 11% less than its value on the surface of the earth. Thus the height of a spacecraft is not the reason for their weightlessness. Their weightlessness is caused by their being in the stage of a free fall through the spacecraft, it not falling on the earth because of its velocity along the orbit. The only force acting on it is a gravitational force on the earth, and therefore it is in a free fall. As the velocity of a free fall does not depend on the properties of an object, the velocity of a free fall is the same for the spacecraft, the travelers and the objects in the craft. Thus, it is the traveler releases an object from her hand. It will remain stationary with respect to her and will appear to be weightless. So friends, here we completed this chapter. Hope it will be helpful to you. Thanks for watching. Thanks Borade sir for giving me this wonderful opportunity, and thanks all of you for giving me your precious time. Thank you. Please like, share, and subscribe Boredom Arts Academy. Thank you.